Have you ever wondered how magnets work? Seriously, how do they attract certain metals like iron from a distance without even touching them? Or why do they have a north and south pole? Or why is the magnetic field around a magnet always in this funny loop shape? Every single thing that you can see around you is made up of atoms, and what happens inside of atoms is wild. First, inside every atom is a nucleus, and their tiny magnetic fields are all pointed in the same direction. So the magnetic field gets stronger. Just like our friend group example, if you had a bunch of paper clips near the magnet, all of their unpaired electrons would align with the magnet, and you'd be able to stick them to the magnet. The nucleus is like the city center of an atom. And around the nucleus are electrons that are whizzing around like cars on a highway. So if you brought two magnets close together, you'd notice that the north pole of one magnet would be attracted to the south pole of the other magnet. But the north pole of one magnet would repel the north pole of the other magnet. Now, it's important to know that the magnetic field lines never connect directly between the two magnets. They form a loop. So this is the magnetic field of two magnets. Notice how the magnetic field lines form a complete loop. This is true for all magnets. The magnetic field lines always form closed loops. Electrons carry an electric charge, and the nucleus does too. But the charges inside the nucleus are positively charged, while the electrons are negatively charged. So what could be attracted to each other here? Well, opposite charges attract. So the negatively charged electrons in the nucleus are attracted to the positively charged nucleus. Like here's one electron going around its nucleus. Can you imagine that would make a tiny magnetic field like this? What's cool is that when all of the electrons in an atom are whizzing around, all of those tiny magnetic fields add up to each other, and they make the atom itself behave like a tiny, tiny magnet. And atoms in your everyday objects, like paper clips or iron nails, have unpaired electrons, which means that their tiny atomic magnets have unpaired magnetic fields. And so they're not canceled out. That means there are a lot of objects around you that are magnetic, but you can't see it because they're not big enough. It's kind of like if you had 100 little friends. Each of them had a weak magnetic field, but they were all lined up in a row. If you brought another person over, that person would feel a pretty strong magnetic pull. But if you took those people and you spread them out randomly, then you wouldn't feel any magnetism at all. In order to understand how magnets work, we need to understand a few things about the structure of matter. Now here's where it gets really interesting. When the electrons whiz around the nucleus of an atom, they actually make their own tiny magnetic fields. So now let's think about a bar magnet. All of the atoms inside the magnet are lined up with each other. Now, all magnets have a north pole and a south pole. And we know that opposite poles attract and like poles repel. And that's how magnets work.